All right, guys, welcome back to another video. We are going to do something a little bit different today. We are going to be um, talking about classes, and we're going to be handling a specific problem that is encountered in all programming languages, and that is floating point uh, rounding errors. If you do something like console.log to 0.1, you're going to get this error. Um, Basically, what happens is, because numbers are stored as binary, a series of 0 and 1s, um, the precision that you get is dictated by whether or not those numbers can be represented within binary. Usually, you won't necessarily see something like this come up. I think if you do like 0.2, I think it works out all right. Yeah. Um, but if the number can't be represented safely in binary, there's a chance that you're going to run into an issue like this. And so there are various solutions. The big decimal library in Java is a solution, and there's a lot of solutions in JavaScript um, that have come along to try to basically replicate that. What I'm going to do today is kind of go over a solution to that. That also, in doing so, we're going to learn a little bit about how classes and constructors work in JavaScript. So you may have seen the syntax before, where you declare a constant or a variable equals new. You can do this. I think I did this with regex in one of my previous videos, where we declared a regex with a string this way. Basically, what we're doing is, so JavaScript has a lot of those built in: regex, string, number, function, stuff like that. There's a variety of different ones. But today we're going to be building our own. So there are different ways that you can do something like this, but the most straightforward way is class, and then declare your class name uppercase letter, and then you would want to start out with a constructor. The constructor is going to take the variables that you pass in when you declare it, and you can use, when you're setting the properties of the object, you're going to say this dot whatever the property name is, and then you're declaring it. And so what this is saying is this dot val is equal to, is the parameter that was passed in, is the type of that equal to string? If yes, then just pass it in directly. Otherwise, convert it to a string. And we'll get into why that is later. But that's, you can use functions and ternary operators here to sanitize it a bit. That's the constructor. If I had other properties, I could put them in there as well. I don't even need to. I don't even need to have stuff that needs to be passed in here. This dot val, or this dot something equals 12. And if I do console log b something, see, console log a dot something. So you don't need to necessarily pass in stuff. It's just that stuff like that you're going to be setting, you can't really modify it when you declare it. You're going to have to modify it through some other means. There are also these things called get and set functions. You may have noticed when something like this, when you have an array, has properties like this. Nope, that's not what I want. Well, let's see. It has properties like this where you don't actually have to use the function calls after it. But the methods that we have do require those parentheses to call them. So how do we establish something like this on our objects? Well, we do it with the get method and also the set method. What the get method allows us to do is essentially just treat some string as if it were a property, even though it's not necessarily a property. So in this case, we are returning the float of this dot val, and float, parse int is sort of like, or parse float is sort of like parse int, except it's going to pass in, periods. So, and what follows after them. So if I do something like this, log a dot num, that's because even though this looks like a function syntax, the way this gets built out is it gets called without those. So, okay. So we've got the constructor, we've got our get methods. We haven't really gone over set. Maybe I'll talk about them in a future video. This is going to be part of a series. Now we need to talk about how we're going to add and subtract. There's a reason why I have input these as strings, and that's because to solve the issue of the rounding error that can but doesn't necessarily need to occur in JavaScript or in any other language, if we take that, in the case of addition and subtraction, less so in multiplication, if we take that number and we split it where the decimal is and break that into two separate addition problems, that's going to be quite easy. And we can do that when that thing is a string. So let's take a look at string. So what am I doing here first? First, I want to allow other decimal objects. I want to be able to say a add b, but I don't want to be able to allow it. If someone says like a add true, I don't want to allow that. If someone adds in a, or adds in like a random string of characters, I don't necessarily want to allow that. So what am I doing here? The first thing, if it turns out that someone's passing in an instance of a decimal object, then I want to set that parameter equal to the value of what was passed in. If the type of the num doesn't equal string, then we are going to set it to string. This one is going to pass it in. This one's going to access it, grab it as a string. So this is mostly when someone passes a number. If someone passes in a Boolean value, that's going to get converted to a string. If someone passes in null, that's going to convert to a string. And the next thing is we got a regex test, which is basically testing to ensure that it's a float value. I pulled this from regexer.com. I haven't done too much testing on it myself. I'm probably going to do some testing. I haven't handled ease yet technically in my solution. Probably something I'm going to get around to though. If it does pass, or if it does pass this test, which keep in mind, passing this test is a negation, it's going to throw a new error. Parameter is not a float. So we can see I call this. Oh, looks like I had a mistake somewhere in line 44. This must not be working. All right, I found the error. As it turns out, I haven't gotten to this yet. This is still a work in progress, but I haven't sanitized the data when it comes into the decimal. So I was declaring it in A, and I should have been declaring it in B. So if I declared it in B, it'll catch. Parameter is not a float. So once it gets past all of these tests, then what we do is we're going to use our destructuring. So this is going to produce an array of two values because there's only going to be one decimal place, hopefully. And on the front of that, you can see basically what we're doing is grabbing this and saying the first part of this is going to be int1 and the second part of this is going to be mant1. Int short for integer, mant short for mantissa. I don't think this is technically a mantissa. I just needed a name. A mantissa is the decimal points on a logarithm. I just used it because it was the first thing I came up with. Something higher because we're going to do the carry later on. Once we do that, we're going to grab the length of both of the mantissas. And then we want n to equal the length of the longer one. And we want m to equal the difference between them. So then we can convert them to numbers. What we're doing here is we are going to need to take something like this. We need to add 0.86 to 0.31675. If we just did that after parsing them as integers, it would add 86 to 31,675. What we need to do instead is add 31,675 to 86,000. And that's why we grab the difference. We say there's a difference of three values here, 10 to the power of 3 right here. And then we're going to multiply the lower value by that. So if x is greater than y, then we're going to take the value attached to y and multiply it by 10 to the power of 3 in this case. And then otherwise, we're going to, or if the other one's greater, then we're going to do the reverse. Now we're going to set the result mantissa or the resulting decimal as the sum of both of those now that we've made that correction. Now what we're doing is checking to see if the result is greater than the length of the longer one as an exponent of 10. So in this case, we've got, it's going to be 10 to the fifth power. 10 to the fifth power is 100,000. If the result is greater than 100,000, we know that these two numbers have gotten to the point where they've added something that needs to be carried over into the ones digit. So if we do that, we subtract 100,000 from it. In this case, it'll be different depending on the length of things. And then we set the carry equal to 1. The carry was declared up here as 0. And in the if statement, it's going to get set to 1. So it's either going to be 0 or 1. In the case of 0, it's not going to affect anything here. Now what are we doing? We're setting the value of the object to the sum of parse int 1 and parse int 2 plus the carry. Then we're converting that to a string, adding a decimal point, and then converting the mantissa to a string and returning this .val. And let's see how that works out. That is the correct answer. it's easy enough to see that this part is correct. 86 plus 31 is, that's going to be 117. We need to carry the 1. 6 plus 5 is 11, plus the carried 1 is 12, and that's what's on front. So I wonder if, let's see if that is one of those that wouldn't be correct in an ordinary calculation. If not, maybe we'll try just oh, you don't need that leading 0. 5.31675. That does actually, that is one of them that works out. Let's try. We already saw that this didn't work out in ordinary JavaScript, so we know this isn't good. This is going to be, that's correct. So we've solved an issue in JavaScript, and we can write something like this for other programming languages too. Most programming languages have some sort of fix that looks roughly like this. We haven't solved the issue of negative numbers yet. We're going to have to do that. We will do that. It's easy to solve that for division and multiplication. Division actually has a lot harder issues to solve. Division is, of the 4 operations, the most difficult. So that's going to have its own video. But let's take a look at subtraction. And again, we can only deal with positive numbers right now. If one of them is negative, we're going to need a little bit more to get us through it. Again, we start out the same way. We destructure X and Y, N, M, carry. All of this is looking the same. We haven't done N. We haven't done the N value. And the reason we haven't done that actually is because we don't actually need to check if it's greater than a certain value because we're subtracting. We need to actually check if it's less. So the check here that's equivalent, we were checking to see if it was greater than or equal to n to the whatever. We're actually seeing if it's less than 0. And if it is less than 0, then we've got to say, in the case of something like we're going to need something, say 9.1 subtract. If we did this normally without accounting for that, what we would get is -2, and we would concat that at the end of 9 decimal point, which wouldn't actually end up being a number. So if we add 10 to the -2, we're going to get 8, and if we tell it to carry, what we should get is 8.8, which is exactly what we want. The carry is going to be subtracting rather than adding in this case because we're doing subtraction. So we add 10 to -2, and we set the carry to 1. We could set the carry to -1 and do an addition here, but we're going to set the carry to 1. Carry, of course, starts out as 0. What are we doing here, though? While mant.length is less than n, we are concatenating zeros in front of the mantissa as a string. And why are we doing that? Well, let's take a longer example. In a case like we subtract this from this, we need 9.006. Well, unfortunately, when we're doing the subtraction, once we do once we parse the ints and subtract one from the other, what we get is 6, and converting it to a string still gets us 6, but we need 006. So we've grabbed the length of the longer one, and we know that it needs to be a length of 3, and we know that those zeros that need to get us to a length of 3 need to be in front of the answer that we have. So we keep on adding zeros in front of the answer that we have until we get the length that we need. Then once we have the mantissa that we need, we can do parse int minus carry to string, and then we can return this dot val. So let's see, 9.006. I'm not sure. I don't know that. I don't know that this one. Yeah, that one doesn't actually produce an error when it's subtraction. See if 0.5 and 0.2 do. No, it doesn't. I'd have to dig through and find errors. They're not always going to happen, and that's part of the issue that people have, is that no one. There's probably a way to tell which ones produce errors when, but if you're not as familiar with them, it can seem somewhat random most of the time, and you need to be able, like, if you're working with decimals a lot, you need to be able to handle them in such a way that is going to not produce errors regularly. So what are we doing so far? We've gone over addition and subtraction. I've got some other functions here. Division is currently not working yet. The root is currently not working yet. Power does work, except for when the power is like power raised to the power of 5 works. Raised to the power of 5.2 doesn't. I need to get root solved before I can handle something like 5.2, because when you're raising something to the power of 0.5, for example, that's the same as getting the square root. And when you're raising a root to the power of when you're taking the 0.5 root of something, that's essentially squaring it. So I need to be able to solve the root before I make more progress on the power. The root is probably going to be the trickiest issue. The division is certainly the second trickiest. Multiplying is actually quite easy, as long as you're dealing with numbers that don't approach the limit of the maximum safe integer in JavaScript. And then I've got this precision thing here. The precision is meant to be, we can talk about this because it's fairly straightforward. The precision is meant to reset the value of this. So if I wanted to do a precision 4, gets us back to 4 decimal spots. It takes in 2 parameters. Rounding is set to true if it's not passed in. I could do, oh, you know what? If I do 2 here, we can see the difference. 2, so 6, 6, it rounded up. If I pass in false, 6, 5. So how do I do that? Again, we're destructuring because we only need the mantissa. We need to declare carry. That's for the rounding. We need to grab the length of the decimal place. While the length of it is less than num, we can add zeros to the end. So if I did something like this, I could get, Oh, I don't have, I accidentally deleted a comma. You just add zeros to the end. Um, that's not that useful, but I stuck it in there anyway. If it turns out that um, we need to be taking stuff off, though, we need to constantly be reevaluating whether or not the carry is true or false. Oh, I forgot I set that to. I set that to a boolean instead of a 1 and 2. So um, while the length is greater than the num, we are parsing the integer at the last digit. If it's greater than 4, we set it to carry to true. If it's not greater than 4, we set it to false. You might be saying, well, it's already set it false. Well, if we're going through and lopping off multiple digits, we need to constantly be checking while in a loop. Probably an easier way of doing this. This is the way I've done it. And then we take the mantis or the decimal place, and we set the substring. We declare it as a substring of the beginning spot up to right before the very end. So the substring, it can take two. It takes 1 to 3 parameters. If you put in 2, the first one is going to be the beginning, and the second one is going to be the end of it non-inclusively. It won't include the last one, the last spot. It'll know to stop right there. So what we do is say, go from the beginning to the end. Don't include the very end, and that's our new string. So we're just chopping off 1 each time. There's definitely ways you can make this a little bit quicker with some math, and I'm going to work on that. But this was just kind of a real quick thing because it's not as important as the other ones. And then if it turns out that round is false, then we don't care. If carry as well, then we need to actually round up on the last value. And then we take off the last one, and then we add on the new one, which is ticked up 1. And then we set the this.val to the new value that we've just found. So I'm going to spend later videos talking about multiplying, hopefully dividing if I can get it working, the power as well. Next time I'll go over the multiplying power because those are pretty much solved. Multiply can even handle negative numbers now. And then, this is going to be kind of a 3, 4, maybe 5-part video. So I hope you guys enjoyed this. Let me know in the comments if you want to see stuff on this. I have a GitHub repository with this available if you want to take a look. If you have some suggestions for what you'd like to see there. This is kind of a side project. JS Big Decimals is probably, I think it's the one that's currently used. It's pretty good. There are some things that I think they should add that they haven't. But for now, it's I think it does a fine job. But anyway, thanks for watching the video. I hope you had a good time. Drop a like, and I'll see you later.